Students, today's class we learned about unit work, energy, power in physics. So we know that it is a syllabus of course 10th class and intermediate, and I'm going to explain the basic concepts. So it is useful for the fundamentals required for the students appearing for JEE, NEET students. In work, energy and power, first we discuss and we learn about the work, energy and power. This is the unit actually. So from this unit first we would learn work. So we have to call in this order. Work from work we can get the energy, then it power. Okay, coming to that work, the work has many meanings. I work in a school or college or factory or somewhere else, and the machine is in working order, and the number of worked out problems in the textbook. There are just some ways in which we use word work, but in physics the work it has a special meaning, so that wherever the word comes work, it is not same. In physics it has a special meaning. So we are going to learn that work in the physics. It represents a physical quantity. In physics it represents a physical quantity. Coming to that, when a force acting on an object and the object moves, we say that the force has done work on the object. So this is the meaning you have to understand. When a force acting on an object, the object moves, we say that force has done work, so that object displaced. For example, we can take some examples. Apple from tree, it is falling. Not only apple, if you take any fruits from the tree, once they matured, they're falling. Why they are falling? Because earth exerted force on the apple. That force work on the apple. Because of that apple falling down. So here force, whatever by means of any way the force is applying on a particular object, that object get displaced, which means the force is done work on that object, so that object get displaced. That is one example. Another example, you can take you take a ball in the hand. If you throw that ball in upward direction, obviously we have to apply the force through the hand. So as long as the ball in the hand, that force is exerted by the hand on the ball. So that force is coming from the hand. That force has done work on the ball, so that ball goes into the upward direction. Otherwise, you take another example. You take this one. If you apply a force through the finger, this object, that box get displacing. So this force is doing work. The force doing work, so that this object get displacing. displacing. So this is the like this you can take several number of examples regarding the work executed on any object. That object get displaced. That object get displaced. To definition of work done. Work done by a force acting on an object is equal to the product of the force and the displacement of the object in the direction of the force. That you have to remember that. Of course, work done is equal to force into displacement, force into displacement of that object, but that displacement direction in the direction, the displacement is in the direction of the force, in the direction of the force. That we have to understand. Suppose this the object is here. Suppose you applied in this direction force. This object is displacing in this direction only. In this direction only. So then that product and so that force and displacement. Let us say that from here to here. Displacement, let us say that force, this is the displacement from some distance, the product of this force and distance equal to work done. Okay, here assume here that the force remains constant during the whole displacement of the object, while there is an object here. You are applying the force. This object is displacing in the force direction. The thing is that while this object is displacing, the magnitude of the force remains constant. It should not be changed. Which means that suppose you apply 2 newtons here, while the entire displacement of this object, suppose that object is from here to here displaced during this displacement, during this displacement, the force remains constant. Let us say that 2 newtons. That should not be changed. That is the assumption. One thing. Work is the product of force and displacement. Work does not have a direction. Please try to understand here. Force has a direction, displacement has direction. That's why they are called vector quantities. Vector quantity means it has a quantity and direction. It is called vector. Suppose it's only quantity or direction, it is a scalar quantity. So here force and force and displacement both are vector quantities. Whereas you are coming to this work it does not have a direction. Suppose this is the object, you are applying the force here. So that that force is working on that object. That object is displacing from here to here. So that product is called force and that displacement is work done. So work done does not have any direction. So that's why work done is a scalar quantity. Is a scalar quantity or a dot product that you have to remember. It is a scalar quantity. Work done is a scalar quantity. It is not a vector quantity because work done has does not have any direction. It doesn't have direction. That's why it is scalar quantity. Please understand. Next, coming to that units of work done, we know that when a force 1 Newton acting on an object and that object moves 1 meter in the direction of the force, the work done by the force is 1 joule, which means that suppose this is the object, your force applied here 1, that force is applied here 1 Newton. So this object get displaced from here to here. The distance is 1 meter. 1 meter. The distance is 1 meter. So therefore, the units of work done equal to force into, let us say, distance d is equal to 1 meter, 1 newton into 1 meter is equal to 1 joule. 1 joule. Work done units 1 joule. This joule is given for this units for this work done in honor of that scientist, British scientist. It has given joules. So Joule, joule. So therefore 1 newton into 1 meter equal to 1 joule. This you have to remember. So like this, it has a unit. It has a unit. So 1 newton meter equal to 1 joule. This is the definition of work done. Now we can learn how to calculation of the work. We know that the direction of the displacement, can have different relations with the direction of the force acting on it. Of course, so their direction may be same, opposite, perpendicular to each other at an angle. Object is the force. This is the force direction. This is the one case. Of course, you apply the force. Because of this force, this object get displaced from here. This is displacing. It is moving in the line of the force. That is the one case. Of course, sometimes another case. Suppose the force is applying in this direction, but this object may be moving in the opposite direction. Another case, this is the perpendicular to each other. Of course, in aeroplane, of course, that mechanically the force is generated, so that it get the force is acting in this direction. The aeroplane is moving in this opposite direction. But in the perpendicular, aeroplane is also taking example for the perpendicular in the sense the aeroplane is moving in this direction, whereas in the gravitational force acting in this direction. The gravitational force is acting in this direction, so that the work done is not the work is not done in the direction of the gravitational force. So in this direction, work done becomes 0. That is the another case. The another case at an angle, which means suppose you take any object. This is the object is here. Unfortunately, the force is suppose accident. So you can see the accident between the two objects, two vehicles may be happened. That collision may be taken any direction. The force is unfortunately acting in this direction. This object obviously need not to go in the direction of the force direction. It may be displaced in this direction, or somewhere else direction. So then displacement and the force direction are different. That's why this unit, this is the displacement direction, this is the force direction. So that's why in this unit we will discuss about these four cases. Displacement in the direction of the force. So displacement in the direction of the force, already I explained. This is the object, you apply the force, this is the force direction. This object is also displacing in the force direction from here to here. That is the first case. Displacement in the direction opposite to the force. The example, while you throw the ball in upward direction also, the ball is moving upward direction, but of course the hand force is there, but gravitational force is also get into that picture. So because of that gravitational force, that ball is reached certain height, that velocity, maximum height where velocity becomes 0, then it is falling down. Then it is falling down. While it is going up, gravitational force is also pulling down that object. That's why its velocity becomes 0 once it reaches certain height. Displacement in the direction perpendicular to the force. Perpendicular to the force. You can take example. You can take example in the railway station porter, coolie. Suppose porter or aeroplane. That is the best example. Aeroplane is also you take an example. So aeroplane is moving in this direction. The force, gravitational force is acting in this direction. Gravitational force is acting in this direction. The airplane is moving in this direction. Displacement is the perpendicular. So work done by this gravitational force becomes zero. Because the displacement is not happening in the direction of the gravitational force. Perpendicular. That is the one example. Aeroplane is the one example. You can take it displacement in the direction perpendicular to the force. Another one, displacement at an angle to the force. You can take example here. For example, suppose there is in the child, or there is a device. This is the cross wall. Sometimes the children, they are playing games. They are sitting here. They are sliding over this surface. So in this case, the force may be acting applied in this direction, but in this direction, the displacement may be the displacement in this direction, vertical direction, as well as the horizontal direction. Case we can understand in the displacement at an angle to the force. We can develop the equations and do the simple problems.